Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore, DG Khan campus.
Quality of service in network. Dear students, this is our continued topic. In the previous lecture, we have discussed about quality of service in network. So in today's lecture, we will complete this topic. So in the previous lecture, we have discussed about quality. What is quality in our daily life? Customer satisfaction is called quality. So when we purchase any product from any shop, if we are satisfied from that product, we will buy the product again. It means that the quality provided by that company is good and we are satisfied. Likewise, if we take the services of a teacher, services of a lawyer, services of a doctor, for the satisfaction level, the services of any person, any company must be very high, so that the customer will go towards that company, towards that person again. So likewise, when we talk about quality of service in network, we hire the services of different companies, different ISPs, different hosting companies, different mobile operators. So the quality of those companies will be high according to network service provision. Outline or contents of today's lecture. Basically, again, this is our continued lecture, so contents are going to repeat. Introduction, quality of service requirements, internet quality of service. We have discussed about these 3 points in our previous lecture. We will study about differentiated services, integrated services, comparison of differentiated and integrated services, conclusion and references. So in today's lecture we will start from differentiated services and we will complete the lecture. Differentiated services. There are 3 points in this slide. We will discuss. Point 1. Differentiated services means a multiple service model that can satisfy the most requirements. Dear students, normally we take different types of services while we use any network. Let's suppose if we talk about a typical PTCL network, we take the services of voice, and using the PTCL service we transfer our voice from one location to another location. So this was typical system of PTCL to provide only voice services. But nowadays PTCL is also providing data services, which is called internet services, and the third most common service which is providing by PTCL is smart TV. So the combination of these 3 services is called a service data model or multiple services data model. So if we need voice services, if we need data services, if we need smart TV services, just we have to go to a single company, which is PTCL, and PTCL provide these services. And the concept of these services is also called broadband services. So nowadays different internet service providers, different hosting companies provide multiple services to its users or to its clients. Second point, differentiated services is used for several mission critical applications and to provide end-to-end quality of service. What is mission critical application? Any application, any program, any softwares which is very sensitive. For example, this application may be regarding our healthcare system. This may be regarding any transportation system. This may be regarding any life saving system. So all the applications which are mission critical, in those applications quality of service is very important. And what is end-to-end quality of service? End-to-end quality of service means the data transmitted from source to destination must receive as it is. So this is called end-to-end data transmission from source to destination. This is called end-to-end data transmission, and quality of service between source and destination is very important, especially in mission critical applications. Last point, differentiated services reduces the burden on network devices and easily scales as the network grows. When the company design a network, that network is designed on the basis of future needs. Let's suppose if the company has 20,000 customers right now, when the network is deployed, this is deployed according to the future needs of the customers. Let's suppose after 10 years, if the customers of that company grow towards 40,000 or 50,000, so current feasibility must be according to 50,000s. Current network resources, current network deployment must be according to future needs. So as the network grows, as the customer enhanced, as the customer plus, the network must be able to provide services to all those customers, but this is dependent on the infrastructure of the network while creating different services or creating different applications or creating different network infrastructure requirements. Differentiated services components. Dear students, this is very important slide. Over here there are some important components or parameters which are very important to provide best quality of service. First of all is traffic conditioning or traffic policing and traffic shaping to ensure that traffic entering the differentiated services domain. Traffic conditioning, basically this is relevant to our data, this is relevant to our packets, this is relevant to our files which are transmitted from one location to another location. So traffic conditioning mean if the network contains some types of restrictions, some types of access control list, some types of IP addresses blockage, then the traffic will not enter. So if the data, if the traffic is very sensitive, then the policies must be according to that. Policies defined must be according to traffic shaping or traffic conditioning. Second is a packet classification. It uses a traffic descriptor to categorize a packet within a specific group. Basically, packet classification means if there are two packets and one packet has least priority and the second packet has highest priority, so the least priority packet may be discarded, but the highest priority packet must be transmitted. So packet classification may be according to the priority basis. Next is packet marking. To classify a packet based on a specific traffic descriptor, every packet contains header. Every packet contains some specific extra information which is called header, and in header there are different parameters and traffic descriptor is one of them. Next is congestion management. Achieve scheduling and traffic queuing. Dear students, what is congestion? when the network is congested, it means if the bandwidth is low and the data or the traffic on that network is high, then your network speed must be slow. Then your network speed may be slow. So if the network speed, if the data transmission speed is slow, this is called congestion. So congestion should be managed, congestion should be controlled so that every user may be able to get data in proper form and quality of service may not be affected. So congestion is very important parameter while we discuss about quality of service. And the last is congestion avoidance. To monitor traffic load to avoid congestion at common network bottlenecks, it may be achieved through packet dropping. So when the network is congested and there is load on the network, when load will be managed, how load will be managed, it is dependent on traffic dropping. As just I have discussed that if there are two packets, one packet's priority is low and the second packet priority is high, the low priority packet may be dropped. So in this way we can control, we can avoid congestion. So these are some important differentiated services components. Differentiated services. There are 3 points in this slide we will discuss. Point number one, first, differentiated services represents a computer networking architecture that specifies a simple, scalable and coarse-grained mechanism for classifying, managing network traffic and providing quality of service. So this model or differentiated service model represent our computer networking architecture. This is complete architecture which is very simple and scalable, enhanceable. We can enhance, it means we can plus multiple customers, multiple users, and a coarse grained mechanism, it means that if there is a problem, if there is a congestion problem, we can handle, we can manage congestion problem with the help of low priority based and high priority based scheduling algorithms, and we can drop low priority based data packets. Second point, a differentiated model is a model that is appropriate for aggregate flows, because this model is used to combine multiple services. So aggregation or aggregate flows mean at the same time we can transmit different types of data at the same time. We can transmit voice, we can transmit data, we can transmit multimedia services at the same time, and this can be achieved with the help of a very smart networking concept, multiplexing. Last point, it alleviates the bottlenecks through efficient management of current corporate network resources. So a differentiated services model alleviates, minimize or eliminate the bottlenecks. Bottlenecks mean the problem, the issues. We have discussed about congestion problem and bottleneck problem in our last slide. So while we enhance our corporate network resources, we can control different types of issues, different types of bottlenecks or different types of congestion problems over here. So differentiated services model is very smart networking architecture which provide enhanced features, which provide quality of service oriented features to its customers, to its corporate clients. Integrated services. Integrated services is an architecture to specify the elements to guarantee quality of service. This architecture is used to provide guarantee regarding quality of service. Integrated services can be used to delete the receiver interruption for the video and sound. If there is different types of interruption on receiver side, this model is used to delete those interruptions. The integrated services idea is to let every router in the system implements integrated services, and let every application requires some kind of guarantees to make an individual reservation. So over here, individual reservation is important while requesting for resources. If individual reservation is allotted, then the quality of service will be high. The integrated services structure can be implemented through the following components: the signaling protocol, the admission control routine. What is signaling protocol? This protocol is used while call setup, and the admission control routine, this is used while requesting for different services. Integrated services, this is like a classifier and a packet scheduler. So what is a classifier? We have discussed about classification. If we have to classify our data packets into two categories, low priority packet and high priority packet, so classifier is used. And packet scheduler means which packet will be forwarded first, which packet will be processed first, so packet scheduler is used for this purpose. Next, this model requires explicit signaling mechanism to convey information to routers so that they can provide the requested resources. Router is a device which is used in wide area network, which is used to transfer our data, transfer our packet from one location to another location, and router is important to provide different resources for those packets which are received by that router. So this model requires explicit signaling mechanism. Explicit signaling mechanism means a mechanism which is defined by a user, which is explicit definition, so that requested resources may be allocated properly. RSVP is one of the most widely known example of such a signaling mechanism. So this is a protocol which is used for signaling mechanism to provide resources for different types of data. Comparison. So dear students, we have discussed about differentiated services and integrated services in detail. So this is a tabular form of comparison between these two services. So we will see precisely over here. Service. Best effort. In best effort there is connectivity, there is no isolation, and there is no guarantees of data transmission. In differentiated services, pre-aggregation isolation is required and per aggregation guarantee is required. And integrated services, per flow isolation, per flow guarantee is required. Second parameter or second point is service scope. In best effort there is end-to-end. End-to-end means from source to destination. And in differentiated services, the domain based, domain for some specific range, for some specific group. And integrated services, again end-to-end transmission. Next is complexity. In best effort there is no setup, there is no call setup, so there is no complexity. In differentiated services, long-term setup, and in integrated services, per flow setup. So in differentiated and integrated services, setup is required. Last is scalability. In best effort, highly scalable, nodes maintain only routing state. In differentiated services, scalable, edges routers maintain per aggregate state, core routers per class state. So over here just main routers are edge routers. Edge routers are those routers which are directly connected to source and destination. Those routers contains different states information. And in integrated services, not scalable, each router maintains per flow state. A conclusions, this is our last slide. The main two traffic management frameworks are differentiated services helps to classify the traffic into number of traffic groups and handles it based on traffic group. So we have discussed in detail that traffic is divided into different groups and differentiated services is helpful to classify these groups. Integrated services based mainly on reserving resources per session and limit total demand on the capacity that can be handled by the network. So second, integrated services are helpful to resource reservation. So these are two mainly traffic management frameworks while we talk about network, while we talk about quality of service in any network.
So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.